picking up where we left off here. So you can see that a zero correlation would have a scatter plot that's spread out pretty wide. And the further you go to the right, the stronger the correlation is, and the scatter plots become a little more distinctly upward sloping to the right, and the pattern of the scatter plot becomes tighter or narrower. And the same thing is true if you were to go with negative correlations, a weak negative correlation like negative 0.1, pretty spread out. And as you get closer to the end, as your correlations get stronger, the patterns become more distinctly downward sloping to the right with a tighter pattern in the scatter plot. So anything in this area we would say is moderate negative correlation. Anything near zero would be a weak negative correlation. Anything near the end we would say is a strong negative correlation. And the same thing for the positive side. Anything near zero is a weak correlation, positive correlation. Anything near the middle is a moderate positive correlation, and anything through the far end near the 1.0 mark would be a positive, strong positive correlation. Well, one of the reasons we like to use correlations is to make predictions. And so based on a strong scatter plot, let's say positive 0.9, we could make a prediction from this data based on the pattern of the scatter plots. And I'm going to show you an example of that in a little bit. I'm going to close that. All right. Okay, so this is actual data from the state of Illinois. This is based on reading test scores, state standardized reading achievement test scores. And every one of the dots on here represents a school in Illinois. The black dots represent McLean County Unit 5 schools, and Pepper Ridge Elementary School is the red triangle. Now there's no significance for that. It's just that to get the data you have to pick a school on the website to get the data. So I just picked Pepper Ridge just because it was close to where my mouse was at the time. But the point here is this shows the correlation between the percentage of students in the school who are meeting or exceeding the state reading standards and the percentage of the children in the school that are low income. So what conclusions can we draw from this? What can you tell me about this correlation? Well, one thing we can say is that in general, schools that have a higher percentage of low-income kids, so you look at all these schools down here in this area who have a high percentage of low-income children, those schools tend to have lower reading achievement scores. And if you were to draw a line from here, all these dots over to here, you can see that a lot of these schools have students who are achieving below the state reading standards. On the flip side of that, you could also say schools that have a lower percentage of low-income kids, like all these schools up in this area, which have low percentages of low-income kids, those schools tend to have kids that score higher in reading and do better on the reading achievement test. You could also say that it's a negative correlation, meaning schools that have more kids with low income tend to have fewer kids meeting state standards. You could also say this is a pretty strong correlation. You'll notice the pattern is pretty tight. And could we make predictions from this? Well, because the pattern is pretty tight, we could make some reasonable predictions from this. If we found out there was a school that had 90% of the students were low income, we could predict reasonably well from this data that those schools, that school does not have a huge number of students who are meeting the reading standards. Likewise, from data like this, if we found out that a school had 5% of its students who were low income, we could predict from this data that that school would have a larger percentage of students who are meeting the reading standards. And that's one of the nice things about correlations, is that we can make predictions. A real-world application might be anything we know that's correlated with suicide risk, for example. It's kind of good to know. So, for example, people with major depressive disorder are at higher risk for having suicidal thoughts or suicidal tendencies. And it's good to know that. If you have a child, for example, or someone you know with major depressive disorder, it would be valuable to know that they may be at higher risk of that. You could watch for signs of things like that. So that's just one of many real-life examples of why correlations are important. I'm going to go back to this example here. All right, let's just say that we did this study that I mentioned earlier, and we asked students to report their GPAs, and we measured their self-esteem. And let's just say that we ended up with a positive correlation with the scatter plot that looks something like this. Okay. Now, one of the things about correlations is that we can't assume one of the variables causes the other. Remember, we're just measuring two variables. We didn't manipulate GPA like an independent variable would be manipulated, and we didn't manipulate self-esteem. You can't manipulate someone's self-esteem. They either have high or low or medium self-esteem, but you can't assign them a level of self-esteem. You can't assign somebody a GPA either. They earn a particular GPA. So what we can do is just measure the variables and see if there's a trend or a correlation between the two. Now, if we found a correlation like this, it might be easy for some people to assume that high self-esteem is causing higher GPAs. And you can see that students with high self-esteem tend to earn higher GPAs. Students with low self-esteem tend to earn lower GPAs. So it might be easy to assume that it's the level of self-esteem that's causing the GPA. But we didn't do an experiment, so we can't assume causation here. It could be just the opposite. It could be that students who earn high GPAs, maybe earning a high GPA causes higher self-esteem. Or maybe earning low GPAs causes lower self-esteem. The point is we don't know really which one is causing which. All we know is that there's a correlation. And we'd have to be cautious about how we report that. That's called the directionality issue. We don't know which direction the causal connection is going. A correlation is just suggesting the possibility of a causal relationship. But we don't know if there is a causal relationship. We don't know which is causing which. There's another way to consider correlations. In addition to the directionality issue, we could always also consider that maybe neither of these variables causes each other. Maybe there's some other variable, a third variable that wasn't measured, that causes these two variables to correlate with each other. For example, maybe self-esteem doesn't cause GPAs, and maybe GPAs doesn't cause self-esteem. Maybe there's something different that kind of causes both of them, like motivation. Maybe students who are highly motivated, I'm going to put an M in there, maybe students who are highly motivated study more and end up getting better grades, and students who are highly motivated do other things in life that make them feel good about themselves, so they end up having high self-esteem. Likewise, students with low motivation would not study as much, so they would get lower GPAs, and if they have low motivation, they might not achieve much in other aspects of their life, which causes them to have low self-esteem. With the third variable problem, as we're talking about right now, there could be lots of potential third variables that are causing this correlation. And we don't know what those are, but we can at least keep an open mind to the possibility that there's some other variable causing this relationship. So on these two slides, I have two more examples of the three ways to think about correlations. This one finds, for example, a research team found a correlation between low self-esteem and depression. We can interpret the results in three ways. Two of those ways come from the directionality issue. We could say, well, it could be that low self-esteem is causing the depression, or it could be that the depression is causing low self-esteem. There's two possible explanations. Or we can consider the third variable. Say maybe neither of those two variables cause each other. Maybe there's something that wasn't measured in this study that causes both of them. For example, maybe people who experience a lot of distressing events, maybe those events cause them to have low self-esteem, and those distressing events also cause depression. Here's one more example. Let's say researchers found that kids who are smart tend to have more friends. Well, we can interpret the results in three ways. It could be the directionality issue, that being smart causes kids to have more friends, but it could be that having more friends causes a kid to be smarter. I suppose maybe they could learn a lot from their friends. Or it could be the third variable issue. Maybe neither of these cause each other. Maybe it's a third variable, like parents who are warm and supportive tend to have kids who are smart. Because they're warm and supportive, they monitor their kids' behaviors and academics closely, and those kids end up being smarter. And because they're warm and supportive, they've also taught their kids a lot of good social skills, which ends up causing those kids to have more friends. So that is one of the major things about correlations. In addition to the direction of the relationship and the strength of the relationship, the fact that we can make predictions from those correlations, especially if the correlations are strong, but we always have to be cautious not to assume that one variable causes another. That's it.